Welcome back. This is an Alex homework video on writing the rate law implied by a simple mechanism. Okay, so a mechanism is basically just an idea that a chemist would have of what's going on, what are the steps involved in when two things are reacting together to make a product. So in the case of, say, nitrogen dioxide here, breaking apart into oxygen and nitrogen monoxide, are there more than one step involved in that? Okay, so a chemist has, in this case, proposed that this reaction may actually happen in two steps. Well, one step is going to happen faster than the other. Anytime you have a new reaction, you see step one is different really than step two, you're going to have a different rate. So the rate constant for step one is not necessarily the same as the rate constant for step two. I'm looking for the slow step here because the rate constant of the overall chemical reaction is going to be the same as the rate constant of the slow step. All right, I'm not interested in one that goes fast. I want the bottleneck. I want the one that slows it the most, and it's going to be as fast as the rate of the entire chemical reaction would be. So I need to know which one is slow. Now, in the case of step one, if step one is slow, because it tells you there which one is fast and which one is slow, if step one is slow, then this is the easiest problem in the world, because all you do is that the rate in that second question, the rate is just going to be equal to the rate of your slow step, which in this case is going to be K times the concentration of NO2. And then your K, the third question, would just be K equals K1. Okay, because it's going to be equal to that first reaction. That would be no problem. I hope you get that kind of question. If you get step two as your slow step, then you're going to have to do a little more work because you're going to have an intermediate here that has to be got rid of. You cannot have a rate law that includes an intermediate, right? So if you were to have your second one as slow, see it says here first step is much faster than the second. That means that your two is your slow step. Okay, so if this one is slow, then what that means is I'm going to just write my K. K2 is going to be equal to, that's the rate of the concentration of oxygen, that's just O, times the concentration of NO2. Well, I can't use that because O is an intermediate. All right, you see that at the product of the first step is just an O, and the reactant of the second step is just an O. But it's not at the beginning of the first and it's not at the end of the second. So this is one that disappears inside the mechanism. All right, so you can't be part of the reaction. So I can't have this O. I can't have this this concentration right here because it's one of the intermediates. So I need to substitute what that would be equal to into my formula. And I'm going to do that through the other step. Now, one of the things that's true, okay, one of the things that I can use is that if I'm looking at the first step, I can say that K1, okay, which happens to be, its rate law would be times NO2, is going to be the same rate as the reverse reaction. Okay, the reverse reaction is to the negative one, so K to the negative one, and its concentration is NO times O. Okay, do you see now I've got a concentration of O that I can solve for? So I can solve for that O, then substitute it in for the top. So this is going to get substituted in for there. So let me simply just put everything else on the other side. I'm going to have K1 times NO2 over K to the negative 1 times concentration of NO equals O. Now I'm just going to put this entire thing in for the O at the top. All right, so I'm going to go back. I'm going to say K2 times K1 times the concentration of NO2. Okay. And then if you can see here, I've got a second NO2 here, so that needs to be part of it. Okay, so this is going to be times NO2, and then I'm going to continue. This is on the bottom. It's going to be k to the negative 1 over NO. Okay, so do you see that this right here is what I substituted for? That was that concentration of O. So this was the concentration of O times the concentration of O2. All right, so that is now, let me just simplify that. What would that be? That's going to be K times the concentration of NO2 squared over NO. Okay, do you see? Because all three of these is considered my K now. All of this is K. So I just have this K times NO2 squared over NO. Well, that's going to be your second. That's what you have second. So my second is going to be K times NO2 squared over NO. Okay, K times, okay, because there's a K here already, K times NO2 squared over concentration of NO. Now they're asking, well, what does your K equal? And my K equals this. Okay, that's my K. So my K is going to be equal to K2 times K1 over K minus 1. And then the easy part, the very easy, is writing the chemical reaction. And the chemical reaction, I'm just going to add. I'm going to add the tops. I'm going to add the tops, top and bottom of the left and the top and bottom of the right. And so I have, this is going to be 2 NO2. And remember, Alex wants you to do the state, so you have to do gas. And then you're going to have on the other side O2, and that's a gas, plus 2 NO, and that's a gas. Okay, so I hope you get the first one where it's the slow in the first step. That's what I want, but otherwise it's not that hard. I think you can do it. All right, I hope that helped.